of CSIR-NET, okay, September 2022. So this video I recorded previously, okay, but due to some mistake, due to some issue on computer, I cannot upload this video. So there is something is written and something is not written, okay. So there written I will discuss, and there is not written after I will write. Okay. So see, I have to change my thing so that you can understand. See, this function is given f from upwards has that fxy equal to like this x minus y square 1 by x minus y even x not y and 0 if x equal to y. Okay, so you have to check its continuity. Okay, this is continuity. So see, for x not equal to x equal to y, if say 0, so it is continuous anyway. So for x not equal to y, for x not equal to y, this part is polynomial, so continuous, and this part is single function, is continuous. So their product is again continuous. So you can say for s not equal to y, this function is continuous. Okay, we have to check at 0 0. So the function is continuous 0 0 if limiting value at 0 0 equal to function value. Now limiting value x tends to 0 0 fxy will be this limit x tends to x minus y square into sine 1 minus minus y. Okay, and this is boundary quantity bounded by 1, bounded by 1, and this is 0. So their product limit goes to 0. Okay, the product limit goes to 0. Now also given f of 0 is 0. So the difference function it is given f of 0 0 is 0. Okay, so f of 0 0 is 0, and you can evaluate this limit by this also. Okay, because sine is bounded by 1, so you can write minus 1 less than sine 1 upon x minus y less than 1, multiply both sides by x minus y, so it's not important na? So limit is not changed. Now this limit just 0, x is 0, this limit goes 0, x is 0, so in between limit goes 0, so this limit is 0, limit 0, so limit x is 0 0 f x y will be 0. Okay, and also f of 0 0 0, so both are equal, so you can say f is continuous. Since both are equal, f is continuous, so option 1 is correct. Okay, now it says the possibility fx is 0 0 doesn't exist, so find possibility f is 0 0. If it's 0 0 is there is formula na, you have to use this formula, you have to use this formula if f is 0 0. Okay, what is the formula? There is a formula of f is 0 0. This is the formula of fx ab, limit if possibility at point ab, limit h tends 0, f of a plus h p minus f of a p upon h. This is the formula. So if it's 0 0, then it will become f of 0 plus h, f of 0 plus h, 0 minus f of 0 0. Okay, minus f of 0 0. So this is by upon h. So this formula I applied. So limit h 0 f of h, 0 minus f of 0. This is 0. Okay, so this everyone apply the definition. If x y is minus y square means h minus 0 square sine 1 h minus 0. Okay, now 1 h will be cancelled. So limit h to 0 is sine 1 by h. Again, this limit is also 0 because this is a bounded quantity and this is limit 0. Okay, so by previous result, this limit also 0. So f is 0 0 0. So f is 0 exists. Okay, but it says option 2 says of f is 0 doesn't exist. Doesn't exist. So it's incorrect, na? Now option 3. Do you understand how this limit 0? How this limit 0? Do you understand? Just think this. Sine is bounded by 1, so you can write 1 upon sine h less than 1. Okay, multiply h both sides, so you get h sine 1 upon h. If h is positive also, okay, if it's negative then it will change. Now take limit h to 0, so this goes to 0, and this goes to 0. Okay, so in between this will also goes to 0. Okay, so this limit will be 0, h tends to 0. So if h is 0 exists, and it is 0. So option 2 is incorrect. Now it says option 3, possibility f is continuous at 0 0. Okay, this one, possibility f is continuous 0 0. See, if you evaluate f is xy, it will be possibility of 2 into x minus y, because the product na, the product. So you have to evaluate it individually. First one, this is derivative, it is stop, and it is stop, it is derivative. Okay, so I evaluate this 2x minus y into sin x minus y plus x minus y into derivative this sin cos x minus y, and this differential minus y square. This part will cancel. Okay, so you have to left with this. Now this is bounded quantity, and this limit x y tends to 0 0 goes to 0. So overall limit goes to 0. Okay, this is no issue, but this part is the issue. If you take limit x y tends to 0 0 of this, then this limit doesn't exist. Okay, this limit does not exist. Okay, because assume f is continuous at 0. Okay, if is continuous at 0 0. So if it's continuous at 0 0, then you must have this limit exist. limit x tends to 0 0 f of x comma y. Okay, this limit should be exist. Okay, but in this case, see, if it's y contains a term on cos of 1 by x minus y, this limit doesn't exist. So this limit doesn't exist, na? So it never continuous. So you can say fx is not continuous. Continuous at 0 0 because it contains a term. This limit x1 tends to 0 0 cos 1 upon x minus y. It contains this term, and this limit does not exist. Okay, if it limit exists na, then it become may or may not be continuous. We don't know. It limit exists, then it happens that it may be continuous, but it is not. The limit doesn't exist. First part limit exists, but second part limit doesn't exist. So how it be continuous? So if it is not continuous. Okay. So option 3 says if possibility f is continuous, so it's also incorrect. Now fourth one, f is differentiable. So for differentiability, you have to know it concept. Okay, I'm writing that. What is that concept? The function is differentiable 0 0. So if it is a function, this function r to r. Okay, this function is differentiable at point ab. Okay, I'm writing in formula. If this limit hold, limit h tends to 0, hk tends to 0 0, del f increment wave minus df, you can say, by root under h square plus k square. This limit should be 0. If this limit is 0, then function is differentiable. Okay, and where del f and df are, what is the del f and df? Del f is increment wave, means it is increment of wave, means a plus h, b plus k, okay, minus f comma. This is increment, ab increment, and df is nothing but hfx 0 0 plus kfi 0 0 no, ab, hf is ab and kfi ab. So in our case ab will be 0 0. So what have to evaluate? You have to evaluate this limit. So if you check this limit hk tends to 0 0, del f minus df, this is 0 or not. Okay, if this limit is 0, then you can say f is differentiable. Okay, you have to check this is 0 or not. So how we check? You have to find this del f and df in this case. Okay, so try to find del f. What is increment wave? It's called increment wave. Here a is 0, so f of a plus h, b plus k minus f of 0 0. Okay, the formula if this will be h minus k square sine upon 1 upon h minus k. F of 0 is 0. Okay, because this part is 0. So now df hf is 0 0 plus kfi 0 0. Now if it's 0 just found this 0, and if is also 0, if you can also find. Okay, because if 0 0 is nothing but this limit k tends to 0, f of 0 0 plus k minus f of 0 0 upon k, this one na, and this is 0. Now it is a limit h k tends to 0, and this is what f of 0 comma k, this is nothing but f of 0 comma k, and this is not but 0 minus k square sine 1 upon 0 minus k. Now 1 k will be cancelled, so this will be k sine 1 by k. Okay, minus k sine 1 by k, and this is also 0. This is nothing but minus limit k tends to 0 k sine 1 upon 1 by k. Okay, this is boundary quantity, this limit tends to 0, so our limit will be 0 na, minus 0 is 0. Okay, so this limit is 0. So f of 0 0, so if this is 0 and this is 0, so a del f will be 0, d will be 0. Okay, so del f will be this and d will be this. So what is this limit? You have to find this limit will be 0. Okay, if this limit is 0, then f is differentiable. If this limit non-zero, then f is not differentiable. Okay, so what will this limit becomes? This will become h minus k square sine 1 upon second part is this is 0 upon root under In we now limit hk tends to 0 0 h minus k square sin 1 upon h minus k. This limit is easily, you can easily solve this limit is 0. Okay, because if you try to find this function modulus, okay, you can easily find that this limit is 0. How? See, this one. Okay, this one. And this is bounded by sin 1 by is bounded by 1. So you can write this h minus k square upon root under h square k square. Okay. Now this limit goes to 0 at h equals to 0. Okay. This limit goes to 0 at h equals to 0. You can easily you because see this power is higher na in this power is higher and this power is lower. So if you take limit h tends to 0, h k tends to 0, this goes to 0. Eh, because in no in two we have no if we approach 0 0, if you want to approach 0 0, okay. So you can approach any path. You can approach this line, this line, this line. You can also curve, also this curve. Okay, many paths are possible. Okay, so and we know limit exit and limit will be unique. So try to go this path, straight line path. Try to go this line, this path. I'm saying try to go through this path. Try to go 0 0 through this path. Okay. So try to put k equal to image. Means I am taking the straight line path. Okay. That goes to 0 0. Straight line path. So if I take the straight line path, so what will be this limit? H square plus k square. This become h minus k square means h square is 1 minus m square. And if you put there here, so get this h put under 1 plus m square. H now if you take limit h to 0, this goes to 0 now. This goes to 0. So this limit is h equals to 0 is goes to 0. Okay, this goes to 0. But this is modulus will be less than this, so this also goes to 0. Okay, so this limit is 0. H equals to 0, this limit will be 0. And this is nothing but this limit dl minus df by root under square. This limit is 0. Okay, so since h equals to 0, dl minus df by root under square plus k square is 0, so you can say f is differentiable at 0. So you can say f is differentiable at 0 0. Okay, so this is the fourth option. There is a theory behind, and this is theory behind this. I have told you that this the theory. If function r is differentiable, this limit exists. Okay, if this limit exists, and not only exist, it will be 0, and what df will be square root of square. Here a b will be 0 0, so I have put a 0 plus h, b plus 0 square minus f of 0 0. Okay, so this is square root and this is df. Okay, and how you find this? This is a df is very trivial. How it is df? You can see df. This df means nothing but dfxy. Okay, so dfxy. So df will be nothing but you can say del x dx, del x dx, and del y dy. Okay. And this special we put h is equal to ds and k equal to dy. So this becomes h fx, okay, plus k fy. Now if you evaluate this limit at ab, okay, so fx will be at ab and fy will be at ab. So this one will become, so I have written df at ab will be hfx at ab plus kfy at ab. And dlf is nothing but dlf at ab is nothing but increment. It is increment. You can say f of a comma b in increment will be h comma k, and this becomes f of h comma k and minus f of a comma b. Okay, so this becomes f of a plus h comma b plus k minus f of a comma b. Okay, this do our formula del f and df. Okay, okay, then you put this limit and try to use this limit 0. Try to find this limit 0. If it's 0, then differentiable. It is not 0, not differentiable. Okay, and one more concept I have used that in two variable in two variable. In two variable, if you want to go 0, okay, there are many paths. You can go through this path, okay, straight line path, okay, y equal to mx. You can go through this path, you can go through this path, you can go through this path, you can go through this path. Because you want, if you want to, I am saying that if you do level R2, if you want to approach at 0, 0, you can, you have many options. You can go through this path x axis, you can go through this path y axis, you can go through this line, you can go through this parabola, okay, you can go through this hyperbola, many way, okay, not only the real case. If you approach to a point x in the real, you have to go in left side or right side, but in R2 there are many ways, okay. So now you know limit is unique. You know, if you go through any path, limit is not change, limit is always unique. You go through this path, if you go through this path, okay, limit is always unique. Limit is unique if it exists. Limit is unique. So I have taken this path, this line path, means y equal to mx, okay, because limit is unique. So if you approach any path, the limit will be unique, na? So I approach this path to find the limit. In this case, in here I have used this line path k equal to mx, okay. So I hope you understand my solution. If you need out, you can always ask in the comment section, okay. So in fourth option is correct in this option, okay. The first two three, so fourth is correct. So option will be 1 and 4. In this question, correct option will be 1 and 4, okay. So in this question, correct option will be 1 and 4. It's the correct option. So if you in doubt, you can always ask in the comment section, okay. In upcoming videos, I will try to upload more videos, solution, okay, and concept, okay. So nothing much is used in this, in visual solution, okay. There are I think three or four concept is used. First law is continuous. We all know this is how function continuous. If function continuous set AB, then limiting value should be function value, okay. In the first part, I have tried to find the limiting value equal function value, and second part, partial derivative formula is used. After that, I have used the differentiability, the differentiability, okay. Okay. Also, if you want to know one more thing, I'm recap the thing what I've used, okay. Recap. A function is continuous. A function is continuous at AB. If only a limiting value, you can say xy tends to AB. If xy will be f of AB. Okay. This formula is used. Limiting value a function value. If function is continuous at AB, then a limiting value is equal to function value. Okay. This is in option 1. Now I have second option I have used this partial derivative formula. If xy at AB is nothing but limit h tends to 0, f of a plus h comma b minus f of a comma b by h, okay. You can write similarly f of a comma b. This is nothing but limit k tends to 0, f of a comma b plus k, f of a comma b by k. See, when I try to find fx, increment will be in a x portion. Increment a will be increased by h, and when I try to find fy, will be increasement will be in b, a comma b plus k minus f comma b by k, okay. And one more formula I have used. The function is differentiable if function from R2 is differentiable at point AB if this limit is equal to 0, del f increment f minus df by root under square plus k square should be 0. Okay, these three factors used. So in this question I have to solve. I have three factors. First one is discontinuity, second partial derivative, and third one will be differentiability. How function from R to R is differentiable. You have to find this limit. Okay, if it's 0, then differentiable. Not 0, not differentiable. So if you need out, you can always answer in the comment section. Okay, I'll try to upload more solutions, video solutions in upcoming videos. Okay, so please follow my channel, subscribe my channel. Okay, so thank you, and card will be 1 and 4.